Electromagnetic induction and force exercise. So this question, figure 9.1 illustrate the left-hand rule which help to describe the force on a current carrying conductor. So the thumb is representing the force. One direction has been labeled for you. What is the index finger represent? For the Fleming's left-hand rule. So index finger is representing a direction of a magnetic field. But you have to mention which direction. So you have to mention it represent the magnetic field direction. Or only write magnetic field, that is correct. Then what second finger represents? Second finger represent the direction of the conventional current, which direction the current moves. No, direction of induced current is a right hand rule. If you are using a right hand, it's an induced current. In a left hand rule is used to find force on the wire, which is placed in a magnetic field. We have a magnetic field. We have the direction of the current. To identify where it will experience a force, we'll use a left hand rule. Figure 9.2 shows a simple DC motor which is connected to a battery and a switch is there. And we have to complete this. So what is the first? That is a carbon brush. And this one is a split ring. Then on a figure 9.1, draw in each of the boxes, we have to name the boxes and then state which way the coil of a motor will rotate when switch is closed and viewed from X. So first, if we close the switch, first we'll draw the direction of the conventional current from positive to negative. So that's how the conventional current will move. So to find the direction of the force on the wire, which is placed in a magnetic field, we'll use the Fleming's left-hand rule. So your index fingers, your first finger should point towards the south, the magnetic field, direction of a magnetic field. In this case, your index finger should point towards the right-hand side. Your second finger point in the direction of the current, direction in which the conventional current is moving. If we say this is side AB, so if you're talking about A and B, so your second finger should represent a direction of a current. So how the current is going? Current is going in this manner. So where your thumb is pointing. So which direction your thumb will point? Use a left hand. Your index finger should point towards south, towards the right hand side. Your second finger point, for we are talking about side AB, your second finger pointing in direction of from A to B. Where your thumb is pointing, you should know the direction of the force. So where your thumb is pointing, the thumb will point downward for side AB. Apply the left hand rule, Fleming's left hand rule. Index finger point towards south, second finger represent from A to B, and your thumb is pointing in the direction of the force. In this case, it is downward. Is it clear? First for AB, the direction of the force?
Yes,
Yes, sir, clear.
Then when you find the direction of the force for side C and B and C will not experience any force because it does not cut the magnetic field. So when we find the direction for C and D, your index finger or your first finger should point towards the south, that is towards the right hand side. Your second finger point in the direction of the current, the conventional current, which is in this case, it is from C to D. This was from A to B. So your first finger pointing towards south, your second finger pointing in the direction of the current. Where your thumb is pointing, that is the direction of the force using a left hand. So your thumb is pointing up. So as one side your thumb is pointing down, another side your thumb is pointing up. So how this wire, this rectangular coil will rotate? So it will, if we look from X, how it will look to us, like how it is moving, it rotates as clockwise. So using the Fleming's left-hand rule, you have to work out its direction. So first identify the direction of the forces, and from direction of the force, you can recognize like which direction it will rotate. State two things which could be done to increase the speed of rotation. So how we can increase the speed of rotation? What we should do? If you want to move it faster. This is a DC motor.
Stronger magnet.
Stronger magnet and
Increase number of coils.
Increase number of coils or turns of a coil. Or a battery which can supply more voltage or current. Or stronger magnet. Or bring the magnetic poles closer also will increase the current or voltage that you can also mention. As they ask for two only, that's why only we should write here two.